Rise and shine, porcupines. It's Algebra with Al time. And I'm your host, Al Rosetti. Today's lesson, Chapter 1, Section 3, Solving Equations and Formulas. In this lesson, you will be able to solve equations and simplify formulas. Why don't we get going? Okay, so before we can start solving equations, we have to understand the language of math. Just like any language, German, you have to understand it before you can really understand what you're doing. So 4 times a number increased by 7. 4n plus 7, n represents the number. Increased is addition. Number 2, 8 less than 5 times the number. 8 less than 5 times a number. So minus 8, that's 8 less than, 5 times a number, 5n. Number 3, 6 times the sum of a number and 5. So the sum of a number and 5, that would be n plus 5. And to multiply that sum by 6, we would have to use parentheses. So it'd be 6 times the quantity, or n plus 5 in parentheses. Number 4, the product of 3 and a number. Well, the product means multiplication, so we know that's 3 times n, or x, whatever you want. Divided by 9. But we don't write the division sign now. We put it as a fraction bar, right? We put it a fraction bar over 9. All right, here we go. 3 times the difference of 4 and a number. 3 times the difference, right? So this is going to be 4 minus n, in parentheses, times 3. All right, the product of negative 11, that means multiplication. The product of negative 11 and the square of a number. So negative 11, n to the second power. You can put it in parentheses, you don't have to. All right, so now we have to go in reverse. We have to take the equation and turn it into a verbal expression. All right, so we have n minus 8 equals 16. You can do this a couple of different ways, honestly. You can put the difference of a number and 8. You can put n subtracted by 8. You can put n less than 8, right? 8 less than a number equals 16, right? So there's several different ways you can write this one. As long as, if you can read this and you can write the equation out exactly the way it is, that's all that matters. All right. Here we go. So the next one. Oh, forgot almost. So for the equals, we're just going to write is 16. The total is, but it's just is. That's all we have to add to that. All right, number 8. Once again, there's a couple of different ways you could write this, as long as it makes sense from translating it from verbal commands to the expression. It doesn't matter. You choose your words the way you want to. But we're talking about 8 plus 3x. So we could write the sum of a number times 3 and 8, right? We could say 8 more than 3 times a number. And in the end is 5. That doesn't change either way. So 3 times the sum of a number, 8 more than 3 times the sum of a number is 5. All right. So let's look at number 9. What do we have? We have a number plus 3, right? You could say it that way. You could say 3 more than a number. You could say 3 increased. A number increased by 3. So those are all different ways you could say it. Is the number. We got to put either the same number or the number. And when we write it, it's got to make people know that you're talking about the exact same value, not a different variable. So 3 more than a number, right, is the number squared or is the same number squared? That's the only way we would make sure we wrote the same variable and thus replace it with the correct value for that variable. All right, and then is, of course, 10. All right, we know that the fraction bar means division, okay? So what are we gonna do here? What are you gonna write? I'm gonna say, how about a number divided by 3 is equal to, right? The product of -2 times a number plus 2. Or 2 less than the product of a number times 2. Anything along those lines, and in the end, you gotta make sure they're equal to each other. But somehow we gotta explicitly make sure that we know we're gonna write y twice, not just some other variable. So it's gotta be a number divided by 3 is equal to blah, 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 to that number, the same number, something along those lines when you're writing it out. Otherwise, you won't write the same variable. And that's exactly what this is. Okay? And in the end, obviously, we're gonna put that they are equal to. So there's several different ways you can write these sentences. As long as they make sense and you can translate the words to the exact equation, it's okay to write it different ways. All right, name the property of each statement. Okay, the first one, if I have a size 12 shoe and you have a size 12 shoe, and you don't know my buddy, but you know he has a size 12 shoe, well then you know you and him have the same size foot, right? That's transitive. You don't know directly, but you know indirectly that it's gotta be equal. And that's what we have on the first one, right? Okay, so the second one, 13. I went down, so if -7x equals 14, then 14's gotta equal -7x. All we did is switch around the terms. That's the transitive property, okay? All right. Look at number 12. What did we do to 12 to go from d plus 1 equals f to d equals f minus 1? All we did is subtract. That's the subtraction property. Don't overthink it. All right, 13. If blah, 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 blah is 30 and 15r equals 30, well, what do you think? It's gotta be, there's one, come on. Think about it for a second. I know you've heard of it before. What did we do? Right? We substituted in. That's all we did. We took what it equals and we substituted in, did the math and substituted. So substitute property. Now these are all properties you need to be able to solve these equations. So whenever we're solving an equation, man, it's so simple. If you just work backwards, starting with 18 and undo everything that's done. I don't care how technical your teacher taught you to do it and how, put a line here, draw. Start with the solution, 18. Working backwards. They add 2, we subtract 2. We're gonna undo everything they did. Think about it like if you get a present, they put it in a box, they put tissue in the box, they wrap it, they put a string around it. And when you open it, you undo the string, you take the paper off, you undo the box, you pull out the tissue paper. So you did everything in the exact opposite order, doing the opposite to get to your present. That's what we're doing here. They multiply by 4, we divide by 4. And in the end, m is 4. And when you plug it in, 4 times 4 is 16 plus 2 is 18. Once again, start with 18, okay? What did we do here? They added 2, right? So there's the check right there. But I don't teach, in my class, I don't teach this formally. I make them sit there with like a piece of scratch paper, start with the solution and work backwards before I start teaching this form, because most students just try to memorize this form and not how to do it. All right, so before we can start solving, you can only have one term with the expression, with the variable and we have 2. So we're gonna combine those. Now I'm gonna subtract the x to the 5x because then I don't have to deal with negative. But you can subtract 5x over to the left side if that's what you're comfortable with. Then once I do that, I'm going to subtract 2 over to the 6 and I get 2. And in the end, it's 1/2. So you can do it any way you want. But why not do it in a way that you do not have to worry about dividing by a negative number? That's what I think. But that's just one more step you have to do that you shouldn't have to. All right, 17. 3t minus, right? Equals 2t plus 5. We have 2 terms with the variable. We can only have 1. Now here we would want to subtract the 2t over to the left side. It keeps it still a positive value and you're done. T is what? There you go, 5. So one step. 18. Once again, we have 2 terms with the variables. We're going to combine those. Okay, now once again, I would want to add the 3b to the right side, to the 2b, so that my variable stays positive. Why wouldn't you want to do that? I know that most of you are used to moving everything to the left side, but why? Because that's how we learned it in middle school. Come on, we're all grown up now, right? So let's add 3b over. We'll add 15 to the left side. You got 22, right? Over 5b equals 5b. We're going to divide by 5, and 22 over 5 is your answer. And leave it like that. Don't make it a mixed number. We're beyond that. Don't put 2 or whatever it is, 4 and 1/5 or 2/5. Just leave it 22 over 5. That's what you do. Okay. So you can see, in the end, we divide by 5, and that's where the 22 over 5 comes in. And like I said, don't get don't get your calculator out. Don't make it a decimal. You know what I mean? Don't make it a mixed number. Nobody likes to see that. At least I don't. All right, so 19. Once again, 2 terms with the variable. We only want 1. We subtract 3x over. I did it this way because I don't think you'd be comfortable doing it the other way. But if this was me, I would have added 5x and then I would have added 24 to the left side. But to kind of keep it in the same format you might be used to, I subtract 3x from both sides. I get negative 8x equals negative 24. Divide both by negative 8. Opposite signs will always be positive when you're doing multiplication and division. And in the end, x is 3. But what did they do? They multiplied by negative 8. We divide by negative 8. Doing the opposite. Undoing what they do. And that's how you get to the answer. 20. Okay, so here you can see we have 2 constants. Once again, we'd only like to have 1, but it's not, in this case, it's not imperative. You could add 6 over and then subtract 20 and it would not change anything. Okay? But traditionally, we're going to combine like terms and then solve. So to do that, 20 minus 16 is 14. Now, start with the answer, 34. You're going to the left side, you see they added 14. What are we going to do? That's right, subtract 14. You get what, 20? Then we have 4 times v equals 20. They multiply by 4. What are we going to do? We're going to divide by 4. And in the end, v is 5. And you can see, opposite, we're always going to do the opposite. We're always going to undo what they do. We're always going to start with the answer and work backwards. All right, now here's an interesting one. How many of you know what to do with that 5 down below? How are we going to deal with that? Well, it's pretty simple, really. Whatever the denominator is in this problem, you're going to multiply every term in that equation by 5. And when you get to the 2a over 5, the 5's divide out because it's 5 in the numerator, 5 in the denominator, and they're going to divide out. But you have to make sure you multiply every term by that 5. So it's 5a. The 5 cancels here, not cancels, wrong choice of words. Divides to 1, and everything over 1 is itself. Then 3 times 5 is 15. We have 2 terms with the variable. You know what to do. Combine them. 5 minus 2 is 3. And in the end, you divide by 3, and a is 5. All right, here we go. Now, here they're trying to give you a decimal to throw you off, right? Trying to add another little wrinkle. But look, think of it in terms of money. If you guys think of that in terms of $2.20 and 80 cents, it's not going to be a problem. You don't need to use your calculators or go through any real, deep theory here. What is $2.20, right? When I add 80 more cents to it, right? What is that? You tell me. $2.20 plus 80. And what am I getting at? So if I put 0.8n underneath the 2.2, that's $2.20 plus 80 cents, that's 3n. Okay? 3n equal, or 3n plus 5 equals 4n. So what are we going to do? All right, we're going to subtract the 3n from both sides. We get negative n. We get n equals 5, not negative. No, I said that. All right, here comes the formula part of this lesson. They want us to solve for p. You're not going to have a number. You're not solving in terms of what you're used to seeing. You would just have the same equation or expression rewritten in a different way, but it's going to be the same values. Nothing's going to change as far as that goes. So what can we do to solve for p? Well, why don't we just divide both sides by r and t, because it's p times r times t. So they multiply by rt, we divide by rt. And in the end, we're going to have p equals I over rt. And that's it. You're not actually solving it, you're just rearranging. And you're going to use the proper order of operations and the proper multiplication or division, whatever it is, to do it. We're going to do the opposites. You're always doing the opposites. All right, 24, sorry. We want to solve for x. Now we just did one kind of like this. What are we going to do to get rid of that 4? That's first and foremost, right? So we're always going to multiply every term in the equation by the denominator. So when we do that, I'm going to get 4 times y, 4y. When I go 4 times 1/4, that's 4 over 1. What happens, right? 4 over 1, the 4's divide out. That's what we want. And leaves us with just x. Then we add 12 over, and look what we get. So you naturally are going to add the 12 first, but I wanted to go straight to how to get rid of the 4. But we're always going to do the addition and subtraction of the constants first. So now we'll multiply everything by 4, and in the end you're going to get 4y plus 48 equals x. We're always going to multiply every term in the equation by the denominator on both sides. Don't think it's just one side. You got to do every term there to get rid of that denominator. And there it is, 4y plus 48. Not solved, just rearranged. All right, 25. What are we going to do here? Solve for y. All right, we can do that. So what are we going to do with the 2 in the denominator? That's actually going to be the first thing we do in this case. There's no plus or minus outside to the right. That's right. We're going to multiply both sides of the equation by 2. On the right side, the 2's divide out. On the left side, you get 2a. Now, 2a equals x plus y. If we're solving for y, what do we got to do? Well, all we got to do is subtract x to the left. And we have 2a minus x equals y. Now, it doesn't look like it's solved, and there's no hard numbers, but that's what they want us to do, to rearrange the formulas, given the variable. All right, last one, 26. Now, they really want to make you think like, oh my God, look at 2 pi r squared, what do I do? 2 pi r, oh my God. But stick to the process. What are we going to do? Well, they want us to solve for h. So why don't we subtract the 2 pi r squared over to the left. Let's do that first. Move it over. Okay, so then we have 2 pi r squared equals 2 pi r to the h, right? Now they want to solve for that h. So think about it. It's 2 times pi times r. Solve for h. Just like as if they wanted us to solve it for coming up with the answer for 2, what would we do? We got pi rh, we would divide that out. So to get h all by itself in this case, we're going to divide in the end by the 2 pi r. So you're gonna have 2 pi r squared over 2 pi r h, 2 pi r equals h, right? So now we'll divide it out, both sides. And then you're gonna leave it just like that. So it'll be a minus 2 pi r over 2 pi r. See, all we're gonna do is divide. And we get h all by itself, and that's what we want. That equals h. So don't let all the variables and the way they wrote it, you're just gonna follow the same techniques that we did solving equations. You're just not gonna come up with a value. At some point, you'll have to stop. Okay? All right, so h in the end is gonna be what? Of course, a minus 2 pi r squared over 2 pi r. And the reason you can't simplify this anymore is because 2 pi r is attached to the a through addition or subtraction. You cannot divide that out. You leave it just like that. The only way you divide that out is if it was 14. A 2 pi r, then that would divide the whole thing. That's it, that's your answer. Well, ladies and gentlemen, thank you for being here today. I appreciate it. I hope this helps. And remember, math, math, math.